So welcome friends to a brand new presentation. Today we are going to discuss about binomial distribution. We had already learned about random variables, expectation and variance of random variables and their computation. Now what is the need and use of binomial distribution? We will see subsequently. But before we go to the distribution, what we want to record here is that while computing the probability, it is often found that there are similar type of questions which we need to answer or similar type of probabilities which we need to compute, and such probabilities can be expressed with the help of a function is a mathematical expression which has some constants and some variables in it. Now for different values of the constants and different values of the variable, we can use those functions to compute the variable compute the probabilities. This gives us an upper hand and easy to understand things than to think of the entire problem from scratch. So while computing the probabilities, mathematicians in the years have developed some distributions, out of which the most simple and popular distribution that we come across is a binomial distribution. So let us see that what is a binomial distribution and when we can use binomial distribution, especially with a focus to the business scenarios. Now let us look at what are the things that we are going to cover in this presentation. First, we are going to understand the binary outcomes with some examples. Then we look at the definition of the binomial distribution and some important properties of the binomial distribution. Having learned that, we will introduce the binomial probability function, which is called as the probability mass function of the binomial distribution, and will understand the parameters of the distribution. Parameters are some constants of the distribution without the help of which or without the knowledge of which we cannot compute the probabilities. So identifying the parameter or knowing about the parameter of the distribution and specifying them quite clearly in terms of the numbers, it is important to know them, without which we cannot compute the probability. So we'll understand the parameters of the binomial distribution. And then we will solve some numerical problems of binomial distribution, and we'll try to understand how probabilities can be computed from binomial distribution, how the parameters can be determined if we know the constants of the binomial distribution, that is the mean and the variance, or the mean and variance of the data, then how we can reach to the parameters of the distribution, and then making some data driven decisions based on the result to which we reach. Now let us look at some everyday understanding of some uncertainties, and actually also in the process we actually try to understand about the Bernoulli's variable. Now what happens in the case of a Bernoulli variable? A particular variable which has only two outcomes like success or failure, yes or no, is termed as a binomial variable, or also called as the binary variable. Not binomial variable, sorry, it's called as a binary variable. So what is a binary variable? A particular variable which has only two outcomes like yes or no, success and failure. So here are some examples. Marketing: will the customer make a purchase? Now suppose I am a sales personnel and I am approaching a customer for selling a particular product or service. Now either at the end of our discussion the customer will buy the product or service, or he or she will actually deny from taking the service. That means there will be either yes, that means I am able to sell my product, or no, I am unable to sell the product. So this is a nice example from business scenario which depicts a Bernoulli variable, that is variable with only two outcomes. In quality control, you know that these days, or means from quite some time, companies, before they send the product to the market, they do a quality control. That means when the product is ready, or even during the process of production, once it is done and once the product is ready, before it is sent to the market, they actually check the quality of the product, at least a sample of product they take, and they check the quality of these units. Now sometimes they find that some product is defective, leading to rejection of the product. And sometimes they find that some products are non-defective, which they send to the market. You might have experienced some cases when you purchase some device from the uh, shop and then bring home and find that it's not working. That is actually defective product, which somehow managed to make it to the market, or might be at the time of testing, the product was doing fine, but later on when it was sent to the market at that time, it in that process of transportation, it got damaged. So these are examples of items which are defective and non-defective. Now, this is also an example of quality control, which comes under the domain of a binary variable, or also called as a binomial variable. Finance, will a loan uh, applicant default? So bank give us loan with the assumption that in due course of time we will repay the loan, the principal and also the interest. But many people are defaulters. They take the loan, but they are unable to repay the principal or the interest to the bank, and they are called as defaulters. Now, when the bank is giving loan to someone, the question comes whether this individual will become a defaulter or not a defaulter. That means he will repay the principal and as well as the interest. So there is a defaulter and non-defaulter, and so that is also example of a binary variable or a Bernoulli variable, that is having two outcomes. Actually, it is also called as Bernoulli variable because this binomial distribution is developed by Bernoulli, James Bernoulli, and hence the variable or the type of variable which has only two outcomes is called as Bernoulli variable. Now, let us look at the operations. Will a shipment arrive on time? Many a times it happens. Whether the shipment will arrive on time. Many a times these days we have a habit of, or we have developed as per our convenience, ordering things online. Now, some products might be such that delay of a day or two doesn't matter much, but some product might be something for which you are waiting eagerly, and you expect that the delivery takes place before the date that has been promised by the company, or the means marketing company which is actually selling the product. But many a times you might have experienced situation where the product does not reach you on time. So whether it will be late or whether it will be on time. So that is uh, an example, binary variable, which is concerned with operations. HR and training, will the employee pass a certification test? So there are some employees who have joined an organization, and the organization has conducted a particular test in order to teach them how to deal with the customers, how to do their job properly, etc. Because they are freshers, have come from studying the different programs, but where they are not given that practical training which is required for that company. So company has arranged a training program, and at the end of the program, company is organizing a particular type of test. Now, out of this, if all of them, means whoever passes this particular test, is then taken to the company and given assigned some job. Otherwise, either that person's candidature will be rejected, or might be he will be given another training so that this time at least the individual can pass. So I, as a trainer, is interested, or as a member of the HR, HR organization of the company, is interested to know whether the person or the employee will pass the certification test, or he or she will fail. So this is an yes, no, pass, fail type of situation. Once again, an example of Bernoulli variable, or say binary variable. That means having two outcomes. Now, these are different examples of a binary variable. That means, and all of these examples that we have given are basically set from a business background. So I think that you can use this example to extend these type of variables in your study area, or whatever type of job you are doing in your organization. Now, in this situation, let me introduce a binomial distribution. Now, I have, say, number of independent binomial variables. That means same type of binomial variables I am repeating once again. That means I am taking, say, last example that I take, let me take, that is the HR example. As a HR example, say, I am taking an individual, and I am checking whether he passes the test or fails the test. Next individual I take, I check whether she has passed the test or failed in the test. Like this, I take n number of individuals. And I found that out of this n number of individuals, x number of individuals have passed. So try to understand this situation. You have a total of say n number of individuals whom you are performing, taking the test. And out of these, x of them have passed. Now you are to find the probability of this x. Okay, this is the job of the binomial distribution. So what is the binomial distribution? A binomial distribution is a discrete probability distribution. I will discuss what is a discrete probability distribution that describes or computes the number of success represented by x in a fixed number of independent trials n, which has the same probability of success. Here we assume that the chance of success is same for each individual. And based on that, we are computing this particular probability. Discrete means here we have, say we have n number of individuals. Let us take a number to understand it better. Say n equal to 10. That means in my organization, there are 10 new recruits. And I have given them that same training, same study material, same type of food, same type of convenience and staying arrangement, etc. And so I assume that each of them have equal chance of passing the particular examination. Suppose I have 8 vacancies which requires to be filled up immediately, and I have recruited 10 people. And I am to find out the probability of x, that means the number of people who pass is equal to 8. Now, if the probability is very high, then I can tell that yes, these out of these 10 people, at least 8 of them will pass and I will fill up my 8 accommodations or 8 vacancies very quickly. But if the probability is very less, say it's 0.3, 0.3 means 30%. That means only 30% chance is there that 8 of them will pass out of the 10 people. Then I am little depressed because I know that even after recruiting and giving them training, I will not be able to fill the vacancies in my organization. So this is we are not discussing the formula. Formula we'll discuss later on in subsequent slides. But let us try to understand why it is discrete. Because the number of people who will pass out of 10. Yes. How many people can pass? There is a possibility that all of them will fail. So if all of them fails, okay. Then what is the chance number of people who pass? All of them fail means number of people that pass is 0. Now say one of them pass. So what is the value of x1? Now say two of them pass. What is the value of x2? I am trying to find out what are the possible values of x. Now if 10 of them appear in the examination, the maximum value that x can take is 10, because what is x? X is the number of people who pass. So the maximum number of people who can pass is 10. So I have the value of x is 0, 1, 2 up to 10. You see here x cannot take values like 0.5, 1.25, etc. That is fractional value is not allowed because these are actually dealing with number of passes out of 10 people who appear. So obviously that needs to be an integer, and that's why we call it here, as you can see, we call it discrete. Discrete because it cannot take continuous values. Okay. And so number of success. So this is the what binomial distribution is all about. That means getting x successes in n trials. In a technical word is getting x successes in n trials. N is the number of times you perform the test. 10 people are there, so each of them sit for a test. So we have 10 trials because each individual is separate. So we have n trials. So this is how the things. So what are the, let us try to understand now. Let us wrap this page little bit because we have already made it dirty. Okay, now let us understand what are the crux or important things of the binomial distribution. First thing is that here the number of trials, that is n, that is a specified number. How many people are sitting in the examinations? How many phone calls I am making to potential clients? Suppose I am trying to call people to purchase my product, or I am approaching customers. How many customers? Say I have approached 15 customers. That number has to be fixed before the experiment actually starts, so that we can find out the probabilities of the some variable up to the value of n. So this number of trials, this is number of people I approach, number of people who sit in the examination, You can have examples from this previous number of products which are tested for quality, number of applicants who apply for loan, number of shipments which will arrive to you. I have ordered a lot for Diwali. So many products I have ordered, say 10 to 15 products I have ordered. So N equal to 10 or 15, whatever. So this is the first thing, very important thing, that the experiment is repeated n number of times and that number is specific. Then comes independent trial. The outcome of the trial is independent of each other. That means my success in a particular case will not influence my success in the next case. Each case is independent of each other. 10 people sitting in the exam, each one of them is answering independently. If first two pass, it does not mean that the chance of passing of the third candidate increases or it may decrease, nothing like that. They are not influencing each other. They are all independent events. So trials are all independent of each other. And we have only two possible outcomes. That's why this is binary variable, and probability of X successes in n binary trials, that is binomial distribution. So trials are two. And the probability remains constant throughout. That is a very important thing. At some point, you might not agree. You may tell that, yeah, well, 10 people are giving the exam. So each of them may not have the same chance of success, even if you give them the same notes, even if you keep them the same living conditions, even if you send them to the same teacher, because their internal intellect may differ. And so the probability of success may change. In that case, we cannot use this binomial distribution. Okay, so binomial distribution can be applied only in cases where P remains fixed. For example, tossing of a coin. This is also an example of a binary variable, because tossing of a coin will give you head or tail. Say you have called tail, so tail is your success. So if you toss a coin, either you will get tail, that is success, or you will get head, which is failure. So head or tail, and then I want to find out that in 10 throws, or say 8 throws or 7 throws, how many times I will get tail. So I have thrown the coin 8 times or tossed the coin 8 times, out of which I want to find out that what is the chance that I will win 5 of the tosses. That means here n in this example of tossing of a coin, your n is equal to 8. Okay, your n is equal to 8. And your number of trials, number of success is x. That means you want to find out 5 successes out of trials. And your probability of success, if you assume that the coin is fair, then probability head is half, tail is also half. So that is probability half. So these we know n, and this you know 2. So this is how the things goes on. And this probability will remain constant for every toss. Not that earlier two were head, now tail will definitely come, nothing like that. In every toss, the chance of a head or the chance of a tail will actually remain the same. Now let us look at this and try to understand the parameters of the distribution. Now parameters, what are parameters of a distribution or parameters of a probability distribution? Parameters of a probability distribution are those constants of the distribution whose value, if we know, we can compute their probability. If we don't know the values of the parameters, we cannot compute the probability, as simple as that. That means in some distribution we will find that there is only one parameter. Some distribution we will find that there are a multiple number of parameter, 2, 3, etc. So here in binomial distribution we have two parameters. One is n. Okay, n. What is the n? N number of trials. That means number of times we repeat the experiment. Shall we take a yellow pencil? So that will make it. And next one is p. That is the probability of success of a single trial. Probability of success. In any single trial, what is the probability of success? Now you may tell that we are computing the probability. How do I know the probability of success? Here is an interesting example. That means you want to sell an insurance product. So you are a working in the marketing division of an insurance company, and your manager has given a list of some individuals, and he has told you that these are the individuals who earlier worked with us, means purchased policies from us. So they are very reliable type of customers. They will listen to you with patience. They will try to understand the policy because they are interested also to purchase policies. After a few days, they keep on purchasing some policies. So for last 3-4 years, they have not contacted us, not taken any new policies. So there is a possibility that they will show interest. So you decide that, because you need to, if someone talks, they will try to know all the details over telephone. Yes, then okay. Some people may tell that we don't have time to talk to you now. But once they have time, they will actually ask you the details of what is the policy, how much is the premium, for how long I require to run the policies. And then is it a deferred insurance, like after a policy premium payment is over, is there any cooling period? What is the return that I will get? What is the death, means return on maturity? What is the return on my sudden death? How many policies, how many premiums I have to pay at my age? What will be the premium? Many such questions. So it takes some time. So this individual has given you a list, and from the list you have actually sorted out that 8 people you will approach before lunch break. So this is 8 potential customers you will be calling. So your N value is 8. Now, how do I know that what is the probability of success? That means if I contact a person, what is the chance that he will actually purchase the policy? Now, previous experiences have told me that from this list given by the manager, if you call, then you will find that 50% of the people will respond to you positively. So that historical information, I have 50%. So 50%, you see what is 50%? 50 out of 100, and that value comes out to be 0.5. So 0.5 is the probability of success. N equal to 8 is the total number of observations or the whom you will contact. So these are the number of trials, and P is the probability of success in an individual trial, and that is 5. And then the binomial distribution is generally X is the number of successes in 8 trials. So X can take the value. What values X can take? It can be 0. No one is interested to purchase. One of them interested to purchase. Two of them interested to purchase. Dot, dot, dot. 8 of them interested to purchase. These are the possible values of X. You may tell that you told 50%. So why I shall go beyond 4? The question is that this is only probabilistic. Means you are to find out that all possible values of X. I am not speaking about all values of X which will have some probability. I am telling about all possible values of X. So I cannot have X equal to 9, because if we approach 8 people, 9 of them cannot purchase the policy because ninth person does not exist at all. You have a maximum of 8 possibilities. If you shoot at the target 8 times, you can have a maximum shot of 8s. You cannot have more than 8 number of shots in target because you are shooting 8 bullets. How can you have the ninth bullet hitting the target when you technically have only 8 bullets? So that is the question. That is the thing which I mean to say. So X will go from 1 to 8. And now if we compute the probabilities, which we will see later on, what we will find is that if you look at the diagram that you have in the left side, well, now, if you look at this diagram, you see for p equal to 0.5, n equal to 8, I have computed the probabilities. How? I will show you later on, because our formula is yet to be introduced. So you see the initially when your x equal to 0, probability is very small, almost very close to 0. Then it increases, then further increases, then further increases and comes down. So this is, you see, as you take p equal to equal probability, so there is a trend that initially the probability shows a rise and then it falls. You don't have probability in between. That is, if I ask you that what is the probability of 2.5, answer is 0, because the probabilities will be available only at integral place like 0, 1, 2, this is 3, this is 4, this is 5, 6, 7 and 8. So at some integral points you will get the probabilities, and you see there is a nice pattern of probability increasing and then showing a decrease. That means as you go to higher values, the probability keeps on decreasing. Remember that the value at x equal to 0 and the value of x equal to 8 is not 0 but very small. So this is what I see in this figure. Okay. Now let us introduce the formula of computing binomial probabilities. So we have understand about the binary variable. We have understand what binomial distribution tries to compute the probability of getting x successes in n repetitions of Bernoulli trials or binomial variables. In n repetitions of a binomial variable, what is the chance of getting x successes? So that is what the probability, binomial probability is compute, and it has some parameters. How many parameters? 2 parameters. What are the parameters? Parameters are called as n, that is number of trials, and p, the constant probability of success in one particular trial. Based on that, we can find the probability of x number of success in n repetitions of a Bernoulli experiment. Okay, the binomial probability of getting x successes in n trials with a probability of success p in an individual trial is given by ncx p to the power x and 1 minus p to the power n minus x. So this is the main formula for binomial distribution. Now, some of the things we know, n we already know, n repetitions of the trial. We know about p, that is the constant probability of success. X we know is the random variable which starts from 0, 1, 2, goes up to n. And p is an integer which takes the value, okay, p is an integer which is actually the constant probability of success, but since it's probability, it lie between 0 and 1. Okay. Now let us try to understand this factor NCX. Some people write it like this NCX. Some people write it like this C n comma X. There are many ways of writing. Some people write in this way also, as you can see here. So I generally write it in this way NCX, and accordingly it is written here. Now what is the meaning of this? It means that in if there are X things, how many ways you can arrange them in n particular places. So this is, suppose I have uh, 5 places, 1, 2, 3, 4, 5 places. So this is 5, that is, this is 5, this is n number of total places that I have. And suppose I have 3 balls. Okay, 1 ball, 2 ball, 3 ball. So this is x equal to 3. So how many ways I can arrange the 3 balls in the 5 boxes? In each box I can put only 1 ball. So what I can do, I can put 1 ball here, the second ball here, third ball here. This is one way of arranging. Another is that I say I delete this. I put this ball I place at the end here. So this is another way of arranging. So there are number of ways in which you can arrange these 3 balls in the 5 boxes. Each box takes only 1 ball. You cannot put 2 boxes in 1 ball. Now this is the possibility. The answer to this is like this, that okay, this is 5C3. Let us have it. Okay, here we have, okay. Let us wipe off some of this text, and then we now here. Before, let us first try to understand this n factorial concept. Here you see we have written like ncx n factorial. This is read as n factorial. This one n factorial. This one we call x factorial. This one called n minus x factorial. This means they are all factorial. If I understand one, I will understand other things also. Let us understand what is n factorial. It's very simple. It is the product of numbers starting from n and decreasing one at a time and going up to 1. That means if I have something like say 3 factorial, what will be 3 factorial? 3 factorial, it can is written like this, is equal to 3 into 2 into 1. That is decrement by 1, and we start with 3, end up at 1. We keep on decreasing unless we reach 1. I have 5 factorial, then what is the value? Is equal to 5 into 4 into 3 into 2 into 1. We stop when we reach 1. So what is the value? 5 into 4s are 20, and 20 into 6 is 120. Quite big a number, isn't it? So this is the thing. Now let us understand what is, say, 5C3. What is 5C3? So let us try to understand this. Let me erase this so that we get a clear view. Now what is this? You see, we have the formula 5C3 is 5 factorial divided by 3 factorial into 5 minus 3 factorial. It is NCX equal to n factorial divided by x factorial into n minus x factorial. Same formula I am using. I have taken n equal to 5 and x equal to 3. So we are getting 5 factorial, 3 factorial, 5 minus 3 factorial. This is 5 factorial divided by 3 factorial into 2 factorial. So 5 into 4 into 3 factorial divided by 3 factorial into 2 factorial. So 3 factorial gets cancelled. And then we have 5 into 4, 20. 20 divided by 2 equal to 10. So this is the called as combination. If you find that, well, the computation is difficult, is there any easy way of computing it? Yes, we do have. We have an Excel formula also. And that is in Excel, any cell you got, you go and you write equal to COMBIN. Then within bracket, the value of n, comma, the value of x. That means 5C3 if you want to compute within bracket 5, comma 3. And then close the bracket, press enter, you will get the value as 10. Remember, don't write combine 3, comma 5. It will give you no result because the value of n you have to write first and then you can write the value of x. Now, these will be used for computing binomial probabilities. Let us directly start with a problem and try to understand how this problem can be solved. This is a binomial. A factory produces microchips. Let them produce. Historically, 5% are defective. A quality inspector take a random sample of 10 chips. What is the probability that exactly 2 are defective? Now, when you are given all these things, first we have to find out that what are the things are available to us from the question. This is the first point. Second point is that we are in the back of our mind, we need the parameters of computing, that is n and p. N and p there, then we can find out the probability for a particular value of x. So here what we have, so this is what I am telling, that for computing a binomial probability for a given value of x, here you see what is the value of x. Value of x is here 2, exactly 2 defective. So here x is 2. What is n? N is here 10 chips. So 10. And what is this 5%? So this 5% I have to, sorry, this 5% I have to take into probability in terms of probability. So that is the thing we need to do. Okay, now come here. N equal to 10. Now this is, we have n equal to 10. This is the probability of number of times you repeat the particular experiment. So that is n equal to 10. Now you see you have here the 5% defective. Here actually finding a defective item is your success. Don't think that, oh, finding a defective is a failure. The question is such that, question is set in such a way that this particular quality inspector, he is in search of a defective item, and that's why defective is taken as his success, because his job is that only, to find out defective items. So what happens here is percentage of finding a defective, it is expressed as 5%. So what is the value of p? P equal to 5%. 5% means, this is interesting, that 5% means 5 by 100. And if you divide, you will find it as 0.05. So that's why it is 0.05. Now n we know, p we know. Now we can find the probability for any value of x. And here we have taken x equal to 2. We earlier discussed. Okay. Now let us look at the probability. Probability, what is the formula? The formula for this is equal to n c x p to the power x 1 minus p to the power n minus x. So now you can put all these values. P 0.05 we have computed, n is your 10, x is 2. So just to put these values, so you get ultimately this. So ultimately 0.05 square is this much. And 1 minus 0.05, that is 0.95, 0.95 to the power 8, this is this, and total you get this value as this one. That means this is the probability. What does it mean? Sometimes what happens, we express probability in percentage. As you have seen in this case also, this gentleman in the question, they have expressed, sorry, so they have expressed this probability as percentage. And so sometimes we can want the result in percentage, is easier to understand. So multiply this probability by 100, which you have found at the end. Multiply it by 100. So this, when you multiply this by 100, for this problem it is not necessary, because they have asked to compute the probability. This much is good enough. But if you want to interpret, multiply it, you get 7.46. Approximately you can take, okay, it's 7.5. 7.5. That means 7.5% chance is there. There is a 7.5% chance of finding 2 defective chips. So that is how we interpret the probability. Now this percentage probability is not very small. It is quite serious percentage, because out of the assigned consignment of 100, if you are sending a consignment of 100, there is a Around 7% chance that two of the consign means units in the consignment will be defective. Okay. Now, customer conversion. This is another problem we are doing. A sales team knows that cold calling leads to a successful sale 80% of the time. Cold calling means sometimes you find that some people call you, tell that you tell your names. You are such and such person. You told that okay. You already under the suspicion that this is probably a call for selling some product because unknown number might be your true caller is telling that business call or promotional call, given some indication that this might not be a useful call. But even then, you don't want to take a chance. You took up the call, yes, then the person tells you, are you such and such? You tell that yes, yes. What is the matter? Then you told that we are calling from such and such bank. Do you want some loan? You told that, no, no, I don't want. I'm not interested in loan. This is cold call. Means they also know that this approach will not work much. So this cold calling. So what is that? Success rate 8% of time. Okay, only 8%. That out of 100, 8% times the bank calls someone that person is interested in taking the loan. Only 8%, 8 out of 100. So a salesperson calls 15 leads, 15 people are called. What is the probability that they make at least one sale? Now this is important, at least one. That means, so what is, so let us look at first the parameters. N is 15 here. Probability success 8% is 8 divided by 100. And so that is 0.08. So we have this. And at least one means one or more than one. At least one means one or more than one. That means what you need to do is that you have to compute the probability of x greater than equal to 1. Now I can x greater than equal to 1 means probability of maybe x equal to 1. Then also it is my success because at least 1. Probability of x equal to 2. Like then also it is my success. So I need to consider this probability also dot dot dot. And then probability if all of them are ready, I make 15 calls. So that is also a possibility. All of this gives my success. So huge computation. In order to avoid this, there is a trick here. That means you calculate the complete probability, complementary probability. That is, no one will respond. X less than 1. What is x less than 1? X equal to 0. And subtract that probability from 1. Subtract that probability from 1. So that will give you the other probability. So probability of x equal to 1. So accordingly, this. So we have this probability. So 1 minus 0.92 to the power 15. So this value, how 0.92? Because 15C0 is 1. So there is 1. Anything to the power 0 is 1. So this is also 1. This is 1 minus 0.8 is 0.92. And whole thing to the power 15 minus 0 is 15. So this is equal to this. So when you take this to the power 15, you get this mark. So the probability is 7.7137. That means when you make a cold calling, expecting that not much success you will get, even then there is 71% chance that at least one people will respond to you. So if you make 15 calls, at least one person, 1, 2, 3, means any number, that chance is quite large. So even there is meaning of some cold calling. And that's why every time I receive a call for bank loan, I think that who will purchase in this way or who will actually take a loan from these calls. But the percentage seems to be quite high because to get a success, at least one means they are getting at least one success is there, maybe more success also. So this is how this probability is computed. Let us look into the shape of the binomial distribution. Here what happens, I have computed the probability of binomial distribution. I have kept n fixed at 10. Okay. And I am taking different values of p. For the first, I have taken the value of p as 0.25. For second, n equal to 10 that I have kept fixed. I have taken p equal to 0.8. Second, and the third one I am taking p equal to 0.75. And I have drawn this, computed these probabilities and drawn this graph. And what we see, initially you see when the probability value is less, means small value of probability, because this goes between p is from 0 to 1. 0 to 1. You may escape this 1, 0 and 1. and you may have P less than P lying between 0 and 1, excluding 0 and 1, because 0 and 1 gives you a constant probability. I mean to say that it is a certain situation where all failure or all success. Other than that, whenever there is a probability of some success, for smaller values of P, the distribution takes a positively skewed. You will find that a long tail coming out in this is a positively skewed. Positively skewed. I cannot call it a car, or I will not call it a car, because I cannot connect it in this way. This is just for visual purpose. I have just connected, but I cannot connect it because I don't have intermediate probabilities. These probabilities are all zero. So I have to look at it like this bars on. When you take P equal to 0.5, that is half, it just increases smoothly and then decreases smoothly. So interestingly, it actually takes, if I am allowed to connect, though I am not allowed to connect because it will not take intermediate probabilities, you will find that this takes a very nice form of a normal curve. And then when you increase the value of the probability even further, constant value of probability, then you see this goes up and comes down sharply. That means this is a negatively skewed curve. Negatively skewed curve. What is the meaning of this? That when probabilities are small, when the probability of success is small, you will get higher values for less smaller values of x. And when probability is at the high end, it's moving towards 1, you will get more number of successes. That means the chance of getting more number of successes for higher values of x for a particular given value of n will increase. So this is quite obvious also. Like if you take an expert shooter, say you are aiming at a target, you are have never taken up an air pistol. So you are that way a novice. And then you are picking up a pistol and you are trying to shoot at the target. So obviously, given your knowledge about pistol and other things, your probability of success will be less. And in such cases, the number of shots out of 10 that you will hit the target will be very less, 2, 3 like that. And so 2 and 3 and 0 and 1, they will have very high probabilities. But if you compete against an expert who goes to the shooting range every day and makes some trial and preparing for national games, say, now that person, I know that he is an expert in that particular sport, so I assume that he will have high probability that P equal to 0.8 or 0.75 like this. And in that case, we will find that number of shots out of 10, 8, 7, 6, these will have very high probabilities. So this is how we understand the binomial distribution through its shape. Now let us look at the properties of binomial distribution. First property is that the binomial distribution has mean of NP. That means if we take the data from a binomial experiment, number of, and then we compute the mean, that means we have the values of x, say starting from 0, 1 to up to 10, and we have take the corresponding probabilities if I arrange them in tabular form, and then I calculate the mean. So this is my x, this is my say frequencies, and I calculate the mean. That mean can be computed with n and p multiplied to each other. It means number of observations into probability of success. Now, if you look at the variance, it's np into 1 minus p. Now, this takes me to a very interesting relationship between mean and variance. That means in a binomial distribution, mean will be greater than the variance, because you see your value of p is less than 1. And so 1 minus p will also be less than 1. Okay, 1 minus p will also be less than 1. So here, this is your mean. You are multiplying the mean with a number which is less than 1. So the variance will decrease even further. So mean will be greater than the variance. And standard deviation of a binomial distribution is given by under root of the variance, that is np into 1 minus p. So the standard deviation is under root of np into 1 minus p. So this is the formula for standard deviation. So here we learn about the formula for the mean, for the variance, and for the standard deviation of a binomial distribution, and also found an interesting relation that mean for a binomial distribution is greater than the variance. Now let us try to find out the mean, standard deviation, and variance given the same salesman calling for cold calling, that experiment. We are revisiting that. So what happens here? N equal to 15, you know, P equal to 0.08. So we have here these values. N equal to 15, P equal to 0.08. This is given in the question. We have seen earlier also. That's why we are not going to the details of it. Now we are to asked to calculate the average. Average is nothing but the mean, where the variance and the standard deviation. So mean is that expectation of x equal to n into p, that is 15, n is 15 and p equal to 0.08, 1.2. It means that on an average, if I make, or means this means that if I make 15 cold calls to people for the purchase of my insurance policy or taking a loan, etc., uh, the average rate is 1.2. That on an average, 1.2 people will accept the offer, 1.2 people will show, 1.2 people will show the interest. Now you may tell that how can 1.2, this is a fraction. No, this is the average value. On an average, 1.2 people, that is little bit more than one people, sometimes one, sometimes maybe two also people, sometimes maybe more also, but on an average it will be 1.2. If I repeat 15 sets of calls, if I say keep large number of people and ask each one to make 15 calls and they are calling to different leads. So if you take an average at the end of the day, we will find that on an average, we have a success rate of 1.2 out of 15. Okay, now let us look at the variance n p into 1 minus p. So this is 15, this is 0.08, this is 1 minus 0.08. So this is equal to 1.104. So this is equal to standard deviation is under root 1.104 and this is equal to 0.05. So this is how we compute the standard deviation. So this is the variance, this is the standard deviation. So this is how we can compute the mean and the variance and the standard deviation. So you see variance is less than the mean because mean is 1.2, variance is 1.104 and standard deviation is 1.05. Now let us look at another example. Here we have mean and standard deviation and we are asked to compute the probabilities. Okay, so mean. So we have mean of the binomial distribution is 40, standard deviation is 6. Be careful, not variance, standard deviation. Okay, find probability of x equal to x. So how to proceed? First we have mean is 40. That means what is mean? Mean is NP. And what is standard deviation? Don't forget to put the square root. Square root of NP into 1 minus p is 6. Now, based on this, we need to find the, when I am asked to find the probability, this, what I mean to, what I want, shall find out that since they have already told that this is a binomial distribution, so actually they want me to find the n and p and define the binomial distribution. Okay, yeah, so let us proceed with this. So you see, first we calculate the variance. Variance is standard deviation square. That means we take the square of 6, that is 36. And what is variance? Variance is NP into 1 minus P. Now we divide variance by mean, that is NP into 1 minus P by NP. So that is 36 by 40. That means here you see this NP and this NP gets cancelled. So we have 1 minus P equal to 9 by 10. So P equal to 1 minus 9 by 10, that is P equal to 1 by 10. So at this stage, now we have no N. What is my N? Do I know N? No, no, I don't know N. I have only computed P. Okay. Now we need to find out N. So what happens? We know the value of P is 1 by N, but we have an equation. You see this equation, let NP equal to 40. We use this. Let NP be equal to 40. Now in place of P, we write the value 1 by 10 and then cross multiply to get N equal to 100. So now we know N. And from this we know P also. Now we can find probability of x equal to x. So probability of x equal to x, if you want to write the formula, this is NCX P to the power x and then 1 minus P to the power n minus x. So 1 minus P is your 0.1, 1 minus P is 0.9 x and n is your 400. So this is the density function. Now if you want to compute some probability, say they ask you the probability, find the probability of x equal to 1. Then what you do, you find a 400 C1 0.1 to the power 1 and 0.9 to the power 399. So you need some calculator to find it out. So this way you can compute the probability for a particular value of x. Now let us see that in binomial probabilities, if I want to compute binomial probabilities, can I take the help of Excel to compute binomial probabilities? And if yes, then what is the formula? So there is an Excel command. They go to any cell and then write this equal to binomial distribution. Then within bracket, you have to write the value of the random variable x. You have to write the total number of times the trial is repeated, and these are the parameter, p is the parameter, and then you write false, capital letter, then you get the value of the probability. For example, here we take an example. Suppose I want to compute probability of x equal to 2. What is the value of n? Is 10, and p is equal to 0.4. Then we have this as binomial distribution in place of x. Don't change the order, please, because x equal to 2, so we write 2. What is n? N equal to 10, 10. What is p? P equal to 0.4, and then here I write false. So in that case, I'll get the value of this particular probability. Now let us look at the cumulative probability. Cumulative probability, why I am writing false here? What is the reverse? If you write true, for example, if you write true, in that case, you will get the cumulative probability. That means cumulative probability is the probability up to that point. What are the values that x can take? Because n equal to 10, so x will take values like 0, 1, 2, dot, dot, up to 10. So what is probability of x less than equal to 2? Less than equal to 2 is the sum of probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. So when you put all these values, and then you get the cumulative probability, this is called as the cumulative probability. So this is how we compute the cumulative probabilities. Now here we have some real world examples where we can apply binomial distribution successfully, and all these examples we have taken up from business scenario. Risk management: calculate the probability of a certain number of loan defaults in a particular portfolio. So you are giving loan. So you are given loan to 10 number of people. What is the probability that there will be one defaulter, two defaulter, three defaulter, at least two defaulter, more than two defaulter, exactly 8 defaulters, so on and so forth. All these questions, all these chances can be computed, and this is risk management. Operations: model the likelihood machine failures to optimize maintenance schedules. So suppose I have 10 machines working simultaneously. Given their history of previous failure, I can find out the probability that in a given day how many failures may take place, and accordingly I can schedule mechanic. If I find that there is a high chance of failure following a particular maintenance, so in that case I can schedule more number of technicians for mending these machines whenever they fail. So this way we can do management or scheduling. Forecast the range of new customers acquiring from a campaign to set the budgets not only in terms of money but also in terms of production. That we had made a new campaign. Now how much the sale will go up, so that I need to pick up with that and produce accordingly. Now, project management: assess the probability of meeting deadlines given individual task success rates. My previous success rate can be actually used to find out that how many jobs I can complete within a given deadline. So these are different ways in which to project risks, etc., can be managed, and examples from marketing is also there. These are the places where you can gainfully apply binomial theorem in a business setup. So thanks a lot for watching this video. I hope that this video has given you a starting point of understanding the binomial distribution and helping you to compute this binomial distribution, which is a way in which probabilistic setup can be utilized to make decisions, and these decisions is data driven decisions, not only decisions based on your whimsical or gut feel, but these are data driven decisions, which is an integral part of modern day business structure. So thank you for watching this video. Be in touch. In case you have some queries, you are free to drop an email in this regard. My email ID is provided there, or you can also write in the comment box below. Thank you once again.